Let's say that I want to go from point A to point B. I can go in many different ways. I can take the car, I can fly a plane, I can go with a boat. I have different options, right? Let's say that I'm seasick, I get seasick, so I can choose not to go with a boat. If it's so far away, I may choose to go with a plane instead of a car. So I have some parameters that I take into account when I'm deciding, like the length of the road or the time it takes to get there. This also applies to algorithms. When we're trying to solve a problem, we can create multiple algorithms to solve that exact same problem and get correct answers. So how can we decide which algorithm to use if we can have multiple algorithms? Well, we will use the most suitable one for us according to the resources we have. So what are the resources? Some resources could be time. It could be time it takes to compute or time it takes to program that algorithm. Another resource could be storage. How much space are we using to run that algorithm? So one thing we want to make sure is that our algorithm analysis should be independent of the computer specifications and the programming languages. So let's say that we ran algorithm A in my computer and it took 3 minutes, while someone else tried algorithm B and that took 4 minutes. Which one can we choose? Well, what if I ran algorithm B on my computer and my computer made it in 2 minutes instead of 4, right? Then suddenly algorithm B sounds better than algorithm A. So it all depends on which computer you're running at, right? Some computers are faster and better than others, and some are slower. So we cannot take computer specifications into account. And the other one was programming languages. So some programming languages are faster than others, and some are slower. We cannot develop different algorithms in different languages and try to compare them. Okay, so now let's talk about how can we do this? How can we do this? Now, we have some candidates here, such as runtime, the execution time. That is, we just talked about. It is affected by the programming language that you may use or the computer you have. Better the computer, faster it will run. So it is not generalizable. That means that this is not a good candidate. Another thing we can do is look at the number of statements. How many statements run in the program? Like do this, add these, subtract that. But number of statements can vary based on the programming language you use. Let's say that you wrote an algorithm with 10 statements in a programming language, but if you use another programming language, you could write that same algorithm with 5 statements. So again, it depends on the programming language. So it's not generalizable either. So another way we can do this is to look at the rates of growth. So rate of growth is basically depending on the input given, how much does our algorithm's runtime change? So it's proportional. Let's say that we gave 10 input and then we gave 100 input, how much the runtime changes. So this way is better than last two because in this analysis it will be independent of the computers and the programming language that we use. Okay, so we know that we should use rate of growth, but how can we do that? And in the next video, we're gonna learn how can we do that.